to yesterday, we have done the delineation part, and then we have put in two substations, watershed outlets, as well as you have seen if at all you have a reservoir, right? Some delineation part. Now we will have the second part, right, where we view the land use, soil, and slope data. Right? So to do that, I think before we go to HL analysis, click on watershed linear. Go to watershed reports. Yeah. Click on topographic report and say OK. So this is something you will get based on the topographic analysis report. We'll have a minimum elevation of 230 meters, maximum elevation of 280, mean elevation is given, and percentage area below the elevation, percentage area of the watershed. Right? So this will actually help you to give some threshold for the different slope classes. Okay, so different percentages of area between percentage, right? What is the percentage of slope that is there? Okay, go down. So it is done for each subbasin as well as the entire watershed. Close it. Yes. Go to HL analysis. Okay, click on it. Right. So if you take the drop down below, HL analysis, there is something called land use, soil, slope definition, epoxy. So this is where you have to give your land use maps, your soil map, and you can define your slope classes based on topography. Right. So before we do that, minimize this window. You people don't have to do it, but just to see. Click on add data. So I'll close it there. Go to realistic. Go to so we added a land use class. Just scroll down. So the land use map that is given is a raster. The raster will have one value in the pixel. Right? In the DEM it is elevation value. Here we have your area values which are between 1, 4, 5, 36, 44, 190. So these values have to make sense for the SWAT model. Right? How do we do that? Go to the folder. Go to the data folder, input data, LULC. This last folder. So each of the value in your pixel should correspond to a land use class which SWAT handles. So for example, value 1 corresponds to corn, 4 corresponds to SDHY, I think which is A or something, 5 is soybean, 6 is sunflower, so on and so forth. Right? You have different land use classes and corresponding SWAT classes. Now how do we get what is a SWAT class? Let's say here everything is prepared for you. You have a land use map, you have this data set as well. But let's say you want to prepare a map for your own catchment, any Indian catchment. You can get the land use data, let's say from NRC, or you get the land use data by your own survey, or you develop a land use using some remote sensing and machine learning techniques. So how do we give those land uses in a SWAT format? Close this. If you go to input data, you don't have a SWAT to go and build database, right? Okay, go to see. Yeah. SWAT, RX SWAT, databases, SWAT 2012. Down. Scroll down. Okay? This is the master database that SWAT uses. Okay, this is the master database that SWAT uses. You can go and edit it. It some crops which are growing, but not all the crops. There are some crops which are growing in your catchment. You can edit or add that information, right? So click on go. Up. There is something for the crop. Click on crop. So you see here. Expand. No. Yeah, double click on the. Yeah. Yeah. Okay. So you see here, object ID, crop name. A 4 letter class for each of them. First one is AGR, generic agricultural language. AGR is also general agriculture. AGRC is your basically row crops, and you can see them here. What is the full name of the crop in this particular column? Okay, I think if you just click on that column, you will see. When you expand it. Yeah, right. Most of the global land use has this generic crop. Row crops, close grown crops. There are orchards, hay, forest, mixed, and everything. Now, SWAT has a crop. SWAT classifies the crop into 7 distinct ones. One which are grown, one which are perennial. There are 7 different classes. I do not recall all the classes, but it is basically to describe 7 different types of crops. And that number is this. So if you go to the SWAT theoretical documentation, you will find out what each number means. Probably 7 corresponds to the forest, where you have a perennial complete year tree, and 4 is basically your agriculture. So each of them have a certain. So if you just scroll down, you have all sorts of crops that are available to you. Again, it doesn't have all the crops that are available. Some crops you may have to add. The first thing that you need to add is classification of the crop, what crop it is. Move this side. Then you have different parameters. Each of the crop will have certain parameters. You can go ahead and see them. Each of the definitions are given in a theoretical documentation. You can identify what of the parameters from the literature, right? This is basically harvest index, maximum LAI of your crop. Then it simulates the crop growth simulation based on the LAI curve and the growth rate. These are those parameters. FRGRW1, LAI max 1, right? The minimum LAI, maximum tree height. This RD max is maximum rooting depth. Optimum temperature for the growth. Base temperature for the growth. It is the minimum temperature for the crop to require. Similarly, you have all other parameters, nutrient uptake parameters, which you can right? Someone asks, how do we get this data? We need to get this data from some agricultural station. Unless we do an experiment and identify this data, it's quite difficult. Okay. So one of the works I did when I was at Purdue was getting this data for a crop. It was basically for a cover crop. Cover crop. The US system, especially the Midwest, has a single cropping system. That's what was a formula available to record. It starts from April, ends in September. In October, it gets too cold, very radiant crop grows. So during the winter time, instead of leaving the field completely barren, we introduced cover crops. So one of the cover crops was cereal rice, which planted immediately after the harvest. It stays dormant during the winter, and immediately during the spring, it starts growing up. So it's a sudden growth. Right? Within 1 month, you can see a crop which is from this height to this height on the ground. Within 1 month, it's a rapid growth. So why they wanted to do that was the snow, when it starts melting, it will take the nutrients. That was the primary source of the leaching, nutrient leaching that was happening into the water bodies. And during the winter, even the soil gets frozen up there. To avoid that, this plant can sustain the winter, stays dormant, and during the summer, it has to. Now, to model that crop, We don't have any equivalent crop here. We had, I mean, it was only for one season. We have taken all the parameters which were there, taking the LAI values, right, and taking the LAI values, all the values which are there. We were trying to fit some of those parameters here, right? Many other crops you get it online from the agricultural repositories. Most of the crops that you make, at least the major crops. Other crops, probably some experimental has to be done. Some major crops will be available. Some of the minor crops you may have to incorporate the system, right? That is what you use your crop database. So SWAT does not have any magic word. Unless the data is there here, it will not. It will keep showing error. Right? So your land use land cover, either the database should be there in the crop or scroll down. Go to urban. Yeah. Or it should be one of the urban land use classes. It should be either agricultural land use classes or it should be one of the urban land use classes. Right? So you will see when you are preparing for your study area, you make sure that your classes are defined in the database. So the SWAT should know what that value means, what the cluster value means corresponding to that particular class. Clear? Okay. Once you have that relationship, you can prepare a CSV file. We have closed the we have shown the initially one CSV file, right? Excel file. You can also see we can prepare it in that sum. Value being the heading, LU SWAT being the heading for that, and we give him this 4-letter code. It's basically a simple GIS operation. How many of you have an idea of GIS? Most of you, right? It's a simple GIS operation which joins a particular value with a table. Right? So that's a simple GIS operation that it takes. But if that linking does not happen, it will not run. Okay? Close this session. Or minimize it. Okay, now go to HRD analysis, land use. Click on the folder next to land use grid, click on that. You can say load land use dataset from the disk, click on open. I think we can load it from the back. Okay. Yeah, you just click on yes. It's already projected. Click no. You click no. Okay. Okay, fine. Choose this. There's no way I can make it better. Okay, so you get a pop-up window that says that land use data have been successfully loaded and click to the watershed boundary. It will say overlap area and percentage of overlap. That is watershed that gets delineated. How much of that land use graph that you are giving, how much of it is getting overlapped. Here we have 100%. SWAT will work till it has a 95% overlap. If the overlap falls below 95%, SWAT will not work. Basically what it does is that 5% margin it is there, it will reclassify on its own. Okay, depending upon what is the national class. But in general, this is a 100% overlap that is there. Click OK. Choose grid field, next is choose grid field, click on value and click on OK. Everyone is here? Now it has taken the value from your raster, what all values are there, percentage area in your entire watershed, and it is asking for what is the this value mean, right? So it is where the lookup table, the CSV file that was prepared that helps to join between this particular value and this particular value. Click on the lookup table. You can, so if it's a US database which you have extracted from NNCD or Cropland data layer, you can directly use it, right? But you can go with the user table. Click on the user table, click OK. Then class code list.csv, it should be a CSV file, click select. Now you see here, based on the lookup, it has already assigned 1 as corn, 4 as GH5, right, 5 as soybean, 36 as alpha, so on and so forth. You can click on reclassify. So basically it will assign those values to those particular classes. Land use reclassify complete, click OK. Okay, go to soil data. Go to the next tab, soil data. Now let's go back to the access database. Yeah. Click on, then click on user soil map. Right. Now your soil map is taken in raster will have a value. You don't know what that value means. Right? If I give you, you will not be able to figure out. But let's say you have the information what the soil is. Let's say history data. How many of you are using history data? ISRIC, history data. It's a global data again, but at a 250 meter resolution, which will give you what do you call it? The percentage of sand, silt, and clay. Okay, basically the textual information in each of the separate raster. Right. Now you can create a map, or you can take it from NBSS and UP. Right, they also have a good map. And if you have the textual information, that information you can fill up. Again, serial number, give it some ID, give it some sequence number. Then you have the name of the soil, some ID. Okay. No. Yeah, let's stop there. This is where you can define what are the number of layers there is. Right? SWAT can take up to a maximum of 10 layers. And you mention for each layer what is the maximum depth and what are the properties. So you have the number of layers. Hydrological soil group. Hydrological soil group is used in your SS number method. And what is the maximum soil depth of your entire profile? Right? From the surface, what is the maximum? For example, first one is about 482 millimeters. Around 48 centimeters is the soil depth. This is 1651 millimeters. Right? The units and everything will be available to you in your typical documentation. And it's also available in some of the this thing. I think soil RNG. Open soil RNG. This one. Yeah, it will give you what each are. Whether it is millimeters, fraction, what it is, right? And what is the data type. Okay, all these things are there. So go back to soil. So you have a soil maximum depth. Go next. This is for the anion exchange. Then you have what is the crack, which is basically for the crack flow. Texture. Soil depth for the first layer. From the surface, what is the soil depth for the first layer? Bulk density, AWC, that is the available water content. This is for each soil. Then for the first layer, saturated hydrogen conductivity, carbon, percentage of clay, silt, and sand, percentage of rock, soil albedo, then USLE K. For each of the soil layer, you can get all these information. SWAT also has, if you go to the SWAT website, there is an Excel file which is basically some of the information gets generated using pedo transfer. So if you know what is the percentage sand, silt, and clay, some of the other parameters carbon, then it will estimate how much. SWAT estimates field capacity and wilting point based on percentage of clay. Field capacity and wilting point is estimated using percentage of clay, and the soil AWC, wilting point is estimated as using percentage of clay. Whatever is the wilting point plus available water content will be your field capacity. The SWAT models your water between field capacity to actually from saturation, but field capacity is where it starts. Anything soil moisture less than field capacity, it starts restricting its use. Okay. So this data again for Indian catchment you must prepare. Okay. So if you are using it for Indian catchment, make sure that you are preparing this data. We try to use the global data, but in some cases, if you want a very specific application, then you have to prepare this. Okay. For example, your soil information is not very critical for your analysis. Go ahead and use the global data set. But in some cases where the soil information is critical, where you are talking about the nutrient transfer, where you are talking about crop yield, it is important that you are representing the soil information as accurately as possible. Right? Those changes will have a lot of impact on your water levels. Right? And it takes some time to prepare this data, but I would say it's worth it. We can do that. Okay. Minimize this. Right now you have done it, so you can go to soil script, click on that, select from the list, load soil data set from the list. You say yes, if the grid or shape are projected. Go to soil, select. Again, you will get a message that it has been clipped to the watershed boundary as soon as you load the soil. And it says what is the percentage of load. Again, in this case it's 100%. Okay. So once it has the 100%, again 95% is the limit where it can work. Just click OK. Choose grid feed, value, click OK. Now SWAT in itself has certain databases. StatsCo and Sergo are the databases that the SWAT has, and Sergo is a database that we have given already in the C drive. Okay, similar to that. But if you have any modifications, you can create the user soil database in SWAT 2012. Okay, so one thing you need to remember is your SWAT 2012 database will be there in your C drive where you have installed the SWAT. But the moment you have set up a model, it will copy that SWAT 2012 in your working folder. Once it gets copied, any changes made in the C drive will not get reflected here. So let's say you have set up the one, and now you have decided that you will use a different soil map. So that details have to be filled up in the SWAT 2012 database that is available in your working folder, not in the C drive. If you make changes in the C drive, it will not get reflected. You will still keep getting errors. Clear? Yes? Any doubts till here? No? Okay. So we have used Sergo database. Click on ArcSWAT Sergo. It has automatically filled up. If you click on ArcSWAT Sergo, it has automatically filled up the corresponding classes. Right? Click on reclassify. It will come as soils reclassified, completed. Everyone is following? Any doubts? No doubts?
Land use course. That is, course is only for region of interest or total India that we are uploading.
If at all, let's say in your region a new land use is there, you can just put it for your own vision. I mean, whatever is the new land use, wherever you apply, if it's there in the database, it will reflect.
Suppose if you take FAO soil, and then we will get any relevant land use codes that given by FAO, only we will get only maps.
Codes you need to develop. SWAT database codes you have to develop. Right? I think FAO SWAT has database in the Texas A&M website, if I'm not wrong. They have a database already, so you can directly use that.
So again, that T03 one data is provided to soil properties data that is in vector format. So can you use
You have to change it to the raster format.
raster format? But the problem is that that whole area is very big. The vector, the shape is very big. We just directly convert it into the raster. So
I think we get individual rasters now. Bhavesh, historic data.
2 degree cross 2 degree maximum tile size.
But you will get as a raster, right? Or
Raster.
no, that is somewhat a different data. So that is the episode and episode. I'm talking about the soil properties data, that bulk density, soil organic carbon.
that is also you get in raster. You can extract in raster. That he has done in his apply. I remember that.
Okay, now they again assimilated 30 second by 30 second data. I think that will go. But they just give them an MBD file and just a table. So they will have to.
You need to extract it in the SWAT format. It will not be readily available. Right?
Join table and then you have to work.
Yes. So, ISRIC data, remember, it took almost 15 days to 1 month to prepare the database, right? It was a comprehensive. Other problem was it will give you a 250-meter tile, and you need to keep mosaicing, and there will be a lot of unique combinations, and for those unique combinations, you need to fill up different aspects. So I think we did some kind of clustering also before we could do that. For which basin? Subardhaka basin. Subardhaka basin, I think he came up with 180 classes.
180.
Yeah, 188 classes. Right. It's a time-taking task. But I am sure you will ask Bhavesh, he will say it's worth it. He was able to sit down and do it in the lab. Okay, but I think if you can automate it, it's possible. If you can do some small coding in the Python or somewhere, where in the ArcMap it gets automated. ArcMap or QGIS, you can automate it, create the file, and create as well as the database file. Right? That is one way of looking at things. Okay? Right. But we must do that if we really want to do the modeling correctly. Global data sets are good for a large scale simulation. The moment you go for a fine resolution, they are not. Right? And probably if you're doing field level, not going to work out at all. The simulation will be completely wrong. Okay, so that is something that you need to think. Okay, Niklas, click on Niklas. Okay. We will have percentage senses here. So there is an Excel file that was created. You just put it in, prepare it in the SWAT format, and you just have to copy paste. Yes. Yeah. Okay. I think you create code on its own. You have to create a code and do what you can. Done?
The soil database option is stats go and user soil data.
So StatsGo is a US data set. Sargo is also a US data set. User soil is if you are creating your own user soil. You open the user soil, right? So if you have a soil in that, you can create it. Okay? Click on OK. We are here following. You can move forward. Yes? Okay. Go to slope. Now your slope gets defined based on your depth. Right? Depth is where the slope is getting defined. Now, if your watershed is more or less similar, there is not much variation in the slope, you can basically choose for a single slope class. In some watersheds, if there is a large variation, now the slope variation will cause changes in hydrological process. A very steep slope will have more runoff for the same soil and everything condition as compared to a flatter slope. So if there is a difference in hydrological conditions of your slope, you can go for multiple slopes. There is an option of taking multiple slopes, right? So depending upon your catchment. Mostly when we do this kind of exercise, we go for 3 slopes. 0 to 2, 2 to 5, 5 to above. Right? And we follow that blindly. Tomorrow you go back, set up your own SWAT model, whatever slope classes I tell you, you go and do it back. Most often it will not affect your simulation that much, but it will increase the number of HRUs, number of computation elements. Now if your catchment size is small, it's fine. If it's a large catchment, increasing the number of HRUs will have significant impact on computation time. It can change from running a SWAT model, which can finish in, let's say, half an hour, it can go up to 1 day. Okay? So, just to show you some classes, put multiple slope, number of slope classes, let's say 3. Put current slope class 1, class upper limit 2, add current slope class 2, upper limit 5. Add. So you see here, there are 3 classes. First class is between 0 to 2. Second class is between 2 to 5%. And third class is 5 to anything above 5. Okay. Now, again I am telling, it depends on the catchment, depends upon your understanding of the catchment, how processes are varying, how processes, like if there is a variation process. If there is no variation in the hydrological process, simply go for a single slope class. So your HRUs will be defined only based on soil and land use. Now since we have given 3 classes, the HRUs will be defined on land use, soil and slope. Okay? Put 3 classify. Slope reclassify completed. Everyone is here? It should not be arbitrary. It should be, see, you should, let's say there is a watershed and you know what is the slope in which a certain area will behave similar. So it comes from some experience, some exploring the watershed. Okay. So I mentioned that you should never model a watershed. We don't do that. We sit in front of our computer and do it. Right? So you have a better understanding. Right? You know whether the model is doing it correct or not. So it makes a difference. Once you visit the watershed, it makes a difference. You can give 3, you can give 2, you can give 0. 1 class. More number of HRUs will get generated because the unique combinations, there is more permutations for unique combinations. Okay. Now you have 2 options. Create HRU feature class. This creates a shapefile of your HRUs. For some applications, creating this HRU feature class is essential. For example, a study we did was on land use optimization. For land use optimization, I should know the land uses that are located, spatial optimization. For that we will record a HRD feature class. You are integrating your SWAT with the modular one. There again you need to have a HRD feature class. Right? So depending upon the application, you can use it. Click on this, let's create. Click on overlay. Okay, it is going to take a little time. So do it, just come back. Over. I don't think so. Go fast. Right, it will take time. done? Okay, any questions in the meanwhile? Any raster format? Only thing is it has to be projected.
Soil has some problems. Try to set up again from starting. No, what I would suggest is start from this. Start from Whether only also.
USWAT is free. RGS you need to buy license. Right? So, well, SWAT model is same. Whether you use QGIS or RGS. Only the interface to prepare SWAT related files changes. Now, usually your RGIS is more stable than QGIS. QGIS sometimes throws some random errors. Right? But I think it's also becoming more stable now. It's not like it's not becoming, it's becoming more stable, but you can use anything, which one is accessible. But the process, everything remains same. The database remains same. The files that get generated remain same. There is absolutely no difference in the generation of files or any other system. Okay.
Slope classes. These are these steps are not there to use
Slope is there.
but directly delineation create a service. These steps are no accumulation, these things are not there.
Is there? Is there? Which are you created? Everyone, which are you created? Not there. Some systems are fast, some systems are slow. Not many people are using this system. That's why it's fast.
Set up a new model. People start setting up.
average slope only. Okay, minimum minus maximum is the longest path. Average slope only. It's not the slope that you should be worried about. You have to check whether the hydrological processes are changing. The slopes may be varying, but if the hydrological processes are not changing, then you don't need to create a separate class. Only if the hydrological processes are varying, different slope classes you have to separate. Okay. Very good. Okay, who is yet to done? What I am seeing is whichever the system our MTech students are using more, they have become slow. Yeah, these are all they use. It's all our we are still not reached track. We are just preparing the files. So you have got an entirely feature class as well. Okay. Actually, let's close the entirely feature class. Actually, they are HRUs. The boundaries are so. This thing, if you zoom in, you will kind of see each and every HRU. Let's uncheck this. Yes. It takes too much time to load every time. Okay. Go to HRU analysis. You have given the land use soil slope definition. You can define the HRUs. Go to HRU analysis report first. Now you can see the land use soil slope distribution across the catchment as well as within the watershed. You have number of 32 substations. 24. This is the second one. Okay. Fine. Probably the models are different. So the next batch will have 34. Okay, no issues. So you will have the percentage of watershed area, percentage of surface area you will get for each land use with soil and soil. That's the report. Okay, close this. HRV analysis. Go to HRV definition. Now here is where we try to reduce the computation effort. Okay. So right now there may be some 2,000 to 5,000 HRUs that have been created. Okay. So we say that this 5,000 computations for 1 day oscillation. 5,000 computations for 1 day oscillation, you might feel okay. Most of the computers should be able to handle it. Right? Now, you multiply with number of days of your continuous model. If it is 10 years, it is 10 into 365 into 5,000. So it has exponential increase. Now, there are different ways of defining your HRUs. If let's say you have defined many number of surfaces, you wanted to delineate a very fine resolution, streamline network, you want to capture all the first order streams. Now usually when you have all the first order streams, and in the watershed, there is some homogeneity. Then we can use this dominant HRU. There are two types. One is dominant land use, soil and slope. A particular HRU, sorry, a particular subbasin, let's say it has 4 land use classes, A, B, C and D. Okay. 3 soil classes, X, Y, Z. And let's say for the simplicity I have only one slope class. What are the possible combinations of HRU? AX, AY, AZ, BX, BY, BZ, CX, CY, CZ, and DX, DY, DZ. That means total of 12 combinations are possible. Maximum of 12 combinations. Now in dominant land use, soil and slope, what it will do is, within that subbasin, it will identify which is the dominant land use. among A, B, C and D, let's say B is the cover 60% area. It would take B. Dominant soil, let's say Z is the dominant soil, 40%. It would take Z and form a HRU of what did I say? What is the dominant axis? B and Z. So entire subbasin will have one HRU, which is BZ. That is what it will create a HRU system. So entire subbasin area will be represented by a single HRU, which is a combination of land use B and soil Z. Now the second aspect is your dominant HRU. In the dominant HRU, among the 12 combinations, it is possible all 12 may be there, or it is possible less combinations are there. And let's assume that all 12 combinations are there in a particular category. Among the 12 combinations, whichever HRU has the maximum area. It may cover only 20% area, it may cover only 30% of the watershed area, it doesn't matter. Among that, whichever is covering the maximum area, that particular subbasin will be allotted as well. Now, in your catchment, when you are having n number of subbasins, you usually assume that the subbasin will be homogeneous. There will not be much of a variation. Right? In such cases, you can go for either dominant land use soil slope or dominant HRU. Third one is the target number of HRUs. If you click on that, you can give number of HRUs that you are saying, let's say 500, I'm okay with 500 or 600. It will reclassify some of the soils, it has an algorithm to do that, whichever is the minimum, it gets reclassified, and it's an iterative process which will count to number of HRUs. For large catchments, what we have done here, where we have subbasins are also big, you can go for multiple HRUs, where you can give threshold percentage for a class. That is, anything less than this, I will not consider. Okay? So let's say here, first option is land use percentage over a subbasin area. Within a subbasin, I will not consider any land use which has an area less than 5%. That is the threshold. Why? Our assumption is, if it is less than 5%, it will not have a significant impact on my hydrology. But at the same time, if you want to capture all the land use to see, then you should give it as 0. Right? But then, if you want to reduce some of the HRUs and say that, okay, if the minor land use gets reclassified, I am not really worried because there is a lot of uncertainty already. Then, in that case, I can go and say land use percentage or subbasin area this. In our case, let me put an example of 10%. I say, okay, anything less than 10%, I'm okay, I can discard. So you just put it on 10%. So your land use area depends on subbasin area. The second threshold is your soil. Soil is within a particular land use. I told you, right? Within a subbasin, HRUs get lumped. So within a particular land use, how much is the percentage area of the issue? It's no more subbasin. Particular land use. Let's say a particular subbasin has a land use with 20 pixels. 20 into, this is 30 meter by 30 meter. Man, so it's a 900. 20 into 900, somewhere around 18,000 square meters. Within that 18,000 square meters, what is the percentage area I'm okay to do? And that is what is the threshold. So let's say soil class also I will put 5 or 10%. Again, depending upon your purpose. It cannot be a random number. Right? Let's say I put 10%. Now, within that soil, what is the slope class percentage? First, land use was on subbasin, soil was over the land use area. Now, within each soil, what is the slope class it has? Let's say 10%. It's same. So what SWAT does is, it will declassify these smaller land uses, smaller soils to other classes. We had A, B, C, D, 4 land uses. Let's say A is only 6%. remaining BCD will correspond to 94%. Now when we are removing this 6%, we have to keep the area constant. So this 6% will get divided between B, C and D, depending upon which one has the maximum area. It depends upon the area proportion. Okay? Now you can say, after putting a threshold, you can say create HRUs. It doesn't consider the spatial. I mean, overlay is done. Overlay means you have fixed it. But the declassification is pretty mathematical. But when you do mathematical, you finally comes down to the area. So it gets divided, the area gets adjusted for each particular class. Looks like our system is slow. Did we get computed and value definition? Click OK. Click on HRD analysis. Okay, click on HRD analysis report, final HRD distribution. It says that you have 32 subbasins and 636 HRUs for me. How much is it for me? Same. 664. 34. And it has increased the number of HRUs. All of you have got 660, right? Because subbasin areas are changing. Right? And because of that, there is higher number of HRUs. You can have, this report will also consist of what is the HRU in which surface. Okay? Close it. Okay, now go to the folder where the model is set up. You don't have to go there, I just wanted to show you this. Right? Go to scenarios. Text in. You see now that this folder is empty. This is the main folder where files get written. Till now there is no file that is written. No. Right? Everything is being worked out. Go back. Go to scenarios. No. Yes. Everything is happening in these two databases. This is the primary database, 2012, from where it is copied, and it is getting written in this access database. Right? Till now, whatever the HRU feature class, everything is getting written here. But SAT does not take its information from here. It needs to have some files from which it takes up. Right? SAT program, it's a model code, it's a code which is program. It needs information in a specific format. So this data that is there in the database has to be converted into SAT format, and that's what it does. The next step. Go to the last one. Go to write input tables. Okay, before write input tables, we have to give the weather data. Forgot about it. go to before that. Let's go to input. Go to your presentation. Gyan course, input data, other precipitation. Now open anyone. Now your precipitation data, you may have a graded data or you may have a observed station data. Now all data must be prepared in SWAT readable format. If it's a graded data, each grid should be having this information, where the first line gives you the starting date and date of entry. That is, first 4 digits corresponds to year, next is month, and next is day. That means this data starts from 1st January 1990, and from there on, all the values of data as it is. Now, if you have some missing precipitation values, then you need to represent that in the form of minus 99. Minus 99 is what? So, in the moment SWAT sees the minus 99, it uses the weather database that we have. I think we will see the weather database also now to fill up the missing values. Okay. Similarly, you have to do it for temperature, but go down. You have to do it for each station separately. Once you do it for each station separately, you need to create a text document that has a list of all these stations. ID, the list should have, format is same. ID, name, lat long. Name is your file name. Whatever file you are creating for each text file that you are creating, that is the name, latitude, longitude, and elevation. Okay. Now, how many of you are used to it? Okay. Question. When you are giving IMD graded data, I'm assuming you are using IMD graded data, right? Now, which station does it take? Does it take the average value? Average of all the grid data? Yes? No? Don't know. Not the centroid of the grid. You will take all the IMDs. It will identify centroid of each surface. Now, the station closest to this centroid is what gets picked up. So, let's say your catchment may have 250 different gauge points, or 250 different IMD grid points. It doesn't use all 250 grid points. It may use only, let's say 10 grid points, where it finds out which station is closest to my subbasin centroid. Now, that entire subbasin will have that particular rainfall, that particular temperature, that particular other factors. Within a subbasin, there is no variability. Within a subbasin, it's only the rainfall that is closest to the centroid. Now, if you have very big subbasin which has a rainfall variation, it will not work. That rainfall variation gets not get represented, even though you are giving it graded data. Right? Don't assume that I am giving you graded data. It will take the spatial variation and it will not. If you want to have the spatial variation, have higher number of subbasins. And sometimes you don't need to give the entire IMD data. Just manually identify which subbasin, what rainfall is there. You can just give in that particular data. It saves time. Okay? Close this. Similar files have to be prepared for all the climate variables: precipitation, temperature, relative humidity, solar radiation, and wind speed. If you don't have data based on the weather generator, it will simulate. Go to the SWAT 2012 database which I have opened here. In this weathergen user. So this is a sample of this thing, right? Now you have this for the India SWAT database. You have it for the India SWAT website, where they have taken the IMD data and generated some statistics. So there is a stochastic model within stochastic climate model based on the statistics. What is the days? What is the I think of any years? What is the maximum temperature, minimum temperature? those factors, the model computes the missing value. Or if you give the weather generator, it will automatically, for a particular location, based on the latitude and longitude, it will compute the precipitation and temperature values. Okay. So this data for the India is already available. You can use it. What each of them correspond or how it computes is clearly given in the first chapter of theoretical documentation. Go back and read that theoretical documentation, first chapter, all the equations are given. You can even do a hand calculation by taking a random value. Okay. It will also give you what each of these variables correspond to. And let's say you have a station and you want to fill up that. You can do that. Again, similar to your land use, similar to your soil, you can do it. And I would suggest that if you want to model it as accurately as possible, you fill weather generator corresponding to your particular basin. Okay? Minimize this question. Okay, go to right input tables, go to weather station, location table. First, it will ask where is the weather generator data. If you have created one, you can go for weather generator user, you can update it. Right now, you take this year scope 1960 to 2010. Right? That is the weather database. Go to rainfall data. That is the weather database that you have taken. Now, once you go to the rainfall data, it asks two things: whether you want to simulate it using the climate model, the weather generator model that you have used, or do you have the rain gauges. We have the rain gauge data, so go ahead and click on the rain gauge data. It has a time listing whether the precipitation is at a daily time step or sub-hourly time step. So you have to choose. Ours is a daily time step, so you can keep it as daily. Go to location table. Go to the start input. Weather data. Precipitation. And you choose the file which has information of all the stations. Easy. Just say open. Similarly, go to temperature. Climate stations. Locations. Go to temperature. Last, there is a TMP file which has all the temperature station data. Click open. Then you have relative humidity, gauges, large storage, okay. Solar radiation, choose solar gauges. Go to solar data and click on solar. Wind speed data is also available to us. Wind gauges. Everyone is here? All done? Anyone? Take all the grid points and do it. Not a problem. It will automatically do it. Yes. No, no, sir. This is the starting. Watershed zero. Delineate and then go back and do it. Once you delineate it, you will get the shape first. It's not like you have to do it continuously. Once you delineate it, you can go back and prepare this data and then do it. Okay, click on OK if you are done. This is a global data. But some of the IoT stations do that. Solar radiation, there are a lot of empirical equations to estimate. Okay. Then click OK.
Computed solar radiation from reach for
There is a FAO manual about 56. Not case of use FAO 56. FAO has a manual for evapotranspiration oxidation. This is for the crop. Solar radiation it will measure based on the Julian day. Which day? This one we have taken from the global data. Done? Okay, click OK and close it. Now write input tables. Now once you have given the data, go and say write swat input files. Now all these input files have to be created in the SWAT format from the database which we have, the database with the project name that you are consisting. That database will get written in the SWAT format in the text file. You can say select all, click on create tables. So it asks whether to use weather database to calculate heat units to maturity. Now there is something which I forgot to tell you. The crop that it gets modeled based on potential heat units. What is potential heat units? It is basically temperature based. Let's say a crop can grow anything above 10 degrees temperature. So anything above that it computes as heat units. Crop will not grow before that. So 10 degrees centigrade, if it grows more than that, 20 degrees, the heat units are 10 on a particular day. So it will keep accumulating from the start of this crop. So when the crop reaches maturity, it depends upon heat units. Now if it's a US catchment, you can use weather database to compute it. Otherwise, for your crop, you need to give. In the crop database that you are giving, you need to give the heat units to maturity as well. Okay? You can use yes because it's a US basin, Sanderson basin. You can just say yes.
There it is only US model that is not for the US we have to take yes. Then India no.
Threshold is going to be same. for a crop. That means a crop requires minimum 10 degrees centigrade to grow. If the temperature is not there, it will be dormant. Okay, that is the whole concept. There is a minimum temperature for the plant to grow. Because plants will be growing even in the winter. Whole reason, I don't know if you have seen some of the trees start shedding leaves. It is because it falls below the temperature and it grows. Since it is having a dormancy, so going into dormancy. Any crop will have a minimum temperature to grow. Let's say it is 10 degrees. For the growing days, since the start of planting, it will find out what is the temperature, average temperature in a particular day, minus the base temperature. Those will be your heat units. And you will accumulate. Then usually your paddy is 120 days crop. You talk in terms of days. But it usually depends upon the temperature. The temperature is high, it will reach to maturity a little bit more faster. The temperature is low, it will take probably a little bit more time. So that is the potential unit. Otherwise, you can use dates. You can know that, okay, whatever be the conditions, the crop is going to go for 120 days, then we can go for a date based. Done building selected tables, click OK. Close it. So now if you go back to your folder, go to scenarios and texting. Now you will see a number of files created which was not there. The moment these files are created, you don't need GIS anymore. I can run my SWAT directly from here. I just need a executable and I can run it. Right? Our work with the GIS part is done mostly. But then there are other aspects in the GIS interface also which can be incorporated into this. Right? Which can be incorporated. But then you can also see how to do that. Right? Close this. I have to give the management practices, but I don't think it's sufficient. Time is sufficient now. Go to edit start input. In the edit start input, you have different components. Point source discharges. If you want to say that the point source that you have given, if you have given some point source, if you want to give the data that is there, inlet discharges, inflow to the inlet discharges. If you have an inflow point that you have given in the starting, that part is there. Reservoirs information. If you have given some reservoir, you have to give different characteristics of the reservoir. When did it start? What is its gross storage capacity? What is the spillway capacity? Right? What are the target storages? All those components. How much is the flow? It doesn't have a very good reservoir simulation module, but it's a decent one. Okay. Then subbasin's data. Click on the watershed data. Go to general data, not BS. Now you see here, it has different parameters and different methods. Click on edit values. Those are all water balance parameters. Some of the parameters. First few are based on the snowfall. Right? Then you have a PET method. Click on PET. You can choose the PET method that you want from here. You can go for Hargreaves, you can go for Christie-Taylor, or you have the potential evapotranspiration values with you can give it as an input here. Or you say read in the PET values. Close. Then you have rainfall runoff method. It has curve number as well as green axis. If you have suboverlay rainfall, you can go for green axis. Otherwise, SCS curve number method, the computations will happen on a daily time scale. So whether you are doing a monthly simulation, yearly simulation, or daily simulations, all computations will happen only on a daily time scale. Clear? It doesn't happen at monthly scale. Daily simulations will get aggregated to monthly, and it will get aggregated to yearly. Okay, close this. have routing, variable storage routing and masking method. Again, you can choose what to do. And then you have host of different parameters that you can consider. Go to nutrients and water quality. So in nutrients and water quality, some of the initialization happens here, right? And then you have atmospheric deposition file that is here. You have bacteria, some of the initialization factors. So this is where you need to go and check, because really looking into that a particular bacteria, particular nutrient, what all these values are, right? Go next. Basin wide management. If you have tile drains, you can install those tile drains. Then there are some additional parameters, which are also, many of these are default values which are randomly generated. Okay. Then there is a urban management or subway erosion. You can. Our USL is computes at what scale? Anyone? Soil loss. Is it on a daily basis, yearly basis, monthly basis? Annual average. So, but it has a module, it's used as revised USL, so it can do based on the rainfall intensity. Close this. Okay. So, giving the management practices we'll do tomorrow, run the model and see the output. Is that fine? Yes?
Soil classification is there are two options, SWAT and SARCO. In the US has one. Why not choose only SARCO soil?
We have taken the server soil.
Why not?
If you take the source is from StatsGo, we take the StatsGo soil. So StatsGo is a more closer resolution compared to soil. Based on that, some is at a state level data, another one is county level data. So we have taken the server data, which is I think final resolution compared to StatsGo.
One more thing, we have chosen heat units are yes. But in the US, within India, we are not choosing a heat unit.
You have to give that. Yes, it will take a default heat units on its own. We take the default heat units on its own. You can modify it for each plot from the database. In the database, you can modify.
Within India also it is calculated based on heat units or not?
You can give both starting date and harvesting date, as well as heat unit. But the plant growth happens with the heat units. So when you say starting day is this, ending day is this, it will take a maximum heat units within that time and do it based on the fraction of heat units accumulated on each day. Okay. The computation of crop growth works on heat units. It's not on daily. The moment we mention that it starts from this date to end in addition particular date, it will take the heat units within those parts. If you want to update a particular database, go right input tables, click on database update. So if you take a particular soil database, you have done some modifications, you will update the database. That's all it is doing. If you are interested only in soil, you will do only the soil part. Okay? Okay, I need to take this one. Just a moment.
Save your file. Save. Save like that.
Okay. So, saves that project, you can close it. T has arrived at the right moment. You can have T and time. Okay.